Let me share my screen. When I share my screen, let me add the chat. Kayla, I think I got you. Steve, got you too. When I go here, I want to, again, make sure that everybody knows that these dates of the 28th are going to be changed to the 30th because based on what happened in the other section, there's an awful lot that we need to get through today, and I think it's going to take more than one day. So proactively, I'm going to push those due dates back. Before we start picking up from where we left off, thank you for getting here. I will try to make sure I email those course invitations to everybody Sunday night or Monday and in the night before. So check your emails for that. Before we get started, does anybody want to look at any of those factoring problems in my labs, the P5?
Could you go over question 9?
I hope so. If I can't get it, then I probably shouldn't be teaching the class, right? So let's see, P5. That was a bad joke. You guys could at least pretend to laugh at my bad jokes. Thank you. That reaction just made my day. What question are we looking at?
Could you do question 9, please?
Okay, thank you.
I think math teachers are supposed to be bad at jokes because my mom's a math teacher and she's very bad at them.
Okay, all right. Give your mom a socially distanced math teacher to math teacher hug for me, okay?
Of course.
All right, factor the following trinomial or state whether it's prime or not. So what we've got here is, let's see, I need a pen that works, right? We've got 6x squared minus 13x plus 6. And when I'm going through it, I'm factoring. I told you folks that to start with, I ignore the middle. I pretend the middle term is not there. So when I'm looking at 6x squared, I'm thinking that it's 3x times 2x or 6x times 1x. When I'm looking at the last term, 6, I'm thinking that it's 3 times 2 or 6 times 1. The next thing that I look for is my signs. Because this one's plus, I know that my signs will be the same, and I'll know that they're both minus. And God damn it, I messed up. First thing I should have said to myself was, is there anything in common? And so I apologize. And so we'll go back up here to the beginning of the list. 13's prime. And so the only thing common between 13 and 6, the only thing common between all of those terms is 1. So that doesn't help me. Because the x squared is in the first term, I'm going to put x's here. And I'm going to put my constants in the back. And so is everybody comfortable with all of those executive decisions so far? What we have to do now then is decide what number goes where. Is there a way that I can get 13 from this? And as I'm looking at it, in order to try to get the 13, I'm pairing these factors with these factors. And as I'm looking at those numbers, the only way I can see of getting 13 is if I take the 3x times the 3, that'll give me 9. And if I take the 2x times the 2, that'll give me 4. And 9 and 4 would give me that 13. So I'm going to use the 3x and the 2x. For the 3 to be multiplied by the 3, they have to be in different parentheses. For the 2 to be multiplied by the 2, they have to be in different parentheses. So now when I check, first 6x squared, outer minus 9x, inner minus 4x, last plus 6, and that gives me that negative 13x in the middle. Trial and error, you know, if you don't play with the numbers first, you're just kind of filling in the blanks with the factors of the first term in the first two spots, the factors of the last term in the last two spots, until it boils to get you what you want. Does that help at all?
I found a really cool way to do like problems like this with a coefficient in front of x squared.
And what did you do?
So I like Googled it. I guess it's called the trash method. So you multiply like the first coefficient by the last term.
And can I tell you something?
Yeah.
If really, 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 really like that method, that's very close to what somebody in the other section called an X box. Some people call it borrow and pay back. I think I was observing a class at Niagara Wheatfield, and they called it slip and slide. If you must factor that way, you can. But I'm going to tell you, if you're in this math path to get on to pre-calculus, calculus, and beyond, your calculus teacher will not like you if you have to use that. It works, but none of us have ever seen a proof as to why it works. And so none of us seem to think that, because it's kind of just like, and also with that, you have to multiply the 6 times the 6, then you have to factor it, then you have to put the 6's back in, then you have to divide the 6 out. There are so many steps in that if you like a checklist of steps to do, it takes you to the answer initially quicker than trial and error. But what usually happens is after about a year, people forget all the steps. But you can do it that way if you want to. I'm not going to like not give you credit if you factor that way, but I'm telling you that as much as it's harder to learn the trial and error, by the time you get to pre-calculus, calculus, and beyond, you get to the point where you can look at the numbers and factor it without doing those middle steps. Do you know what I'm saying?
Yeah.
So it's not what you wanted to hear. But and let me know if I'm got your, actually, you're saying that you want to change that into x squared minus 13x plus 36, and then you factor that, and then you do something weird to put the 6 back in?
No.
No. What do you do?
So, like.
Or is it that what we had called the AC method, where you've got the 6x squared minus 13x plus 6, and you take them and you get 36, and then you look for factors of 36 that add to 13?
Yeah.
And then you change that into, okay, yours isn't as bad as I thought.
You turn it into like 6x minus 9, 6x minus 4, and then you factor out like the 6x minus 9 to 2x minus 3.
So you change that into 6x squared minus 9x minus 4x plus 6, and then you do your factoring by grouping?
Yeah, basically.
Yeah. That one's not as bad as the other ones. And so I apologize for berating you early on. So that was what we had called the AC method, which falls back on the factoring by grouping. But again, it takes middle steps. So at this stage of the game, whatever method of factoring works for you. But if you can get used to that trial and error, you get to the point where you can just look at the trinomial and see the factors. So, okay. Does anybody want to try any others? If not, I'm going to leave the homework and go back to where we left off. And where we left off was simplifying rational expressions. And we had done one example, but only one, and I want to do more than one example. So let's look at x squared minus 8x plus 16 over 3x minus 12. And as a refresher, does everybody remember that we said that the first thing you have to do is factor? And what we have to factor is each numerator and each denominator. I usually go for the one that looks easiest to factor first. That denominator is 3 times x minus 4. And then I try to see, can x minus 4 be a factor of that numerator? And it turns out that that's x minus 4 times x minus 4. And then we said we could divide out those common factors. And we're left with x minus 4 over 3. Does everybody remember that from last class?
Yeah.
If so, I'm going to shut up. And I'm going to give you another one, and I'm going to multitask. I'm going to ask you to do two things. I'm going to ask you to simplify and state the domain. And I'm going to look at y squared minus 4y minus 5 over y squared plus 5y plus 4. And I'm going to give you guys like maybe a minute and a half. Or if everybody gets done sooner. So please simplify that, but also before you simplify it, state the domain and we'll see how everybody does. Wait a minute. Wait a minute, wait a minute. We didn't simplify last class. I'm sorry, that's where I stopped at the 11 o'clock class. Are you folks all right with that simplifying, with that factoring? Nobody's talking to me. Is everybody all right with that last example?
I'm good with it.
Everybody else okay?
Yeah, I'm good.
Okay. How is everybody doing with their factoring? Should I wait another couple seconds or should we go over? Can we go over?
Yeah.
Yep. Okay, so numerator y squared minus 4y minus 5. We've got y and y. 5 can only be 5 and 1. The signs are different. If I make the 5 negative and the 1 positive, it'll give me the -4 in the middle. Then in the denominator, y squared is y times y. I don't think I can get the 5 in there, but if I try to get the +1 in there, the other factor would be +4, and it works. There's a common factor that divides out. So I'm left with y, pardon me, y minus 5 over y plus 4. That part all right.
Yep.
When you look at the domain, what you have to realize is that we're going to the original. And so the original would be the product y plus 1, y plus 4 in the denominator equaling 0, which would give me y plus 1 equals 0, or y plus 4 equals 0, which would give me y equals 1. I'm sorry, y equals -1, or y equals -4. And so for the domain, we'll say that y cannot equal -4 or -1. And I want to give you a heads up, in my labs with these questions, they ask you to put those numbers in order. And usually it doesn't matter if they're in order or not, but the directions in my math lab asks you to put those in order. And when it comes to some of the more involved problems we're looking at later, the division problems, I have had some students do it correctly and get the right answers and get very frustrated because they're marked wrong. But be careful. If the directions in my lab says put the numbers in order, you really have to. Is this example okay for everybody? In both the domain part, it comes from setting the denominator equal to 0, and the reducing part, which comes from factoring everything. If so, I'd like to look at a special case. Can I scroll up?
Yep.
So next example, I want to look at x minus 2 over 2 minus x. And as I look at those, is that numerator and the denominator the same? No, because the subtraction's reversed. And with subtraction, order matters. And so if the subtraction is reversed, they're opposites. And so if I leave that numerator the same, in the denominator, if I divide out a -1, I'd end up with x minus 2. And so those x minus 2's will cancel and leave me with a -1. And so we're going to be able to say, in general, if I have a minus b over b minus a, if I have factors in a fraction, numerator and denominator, they're both subtractions. They're the same quantities, but in reversed order, that will always reduce to -1. You have to be careful though. If it's subtraction and the order is reversed, it'll give me -1. If it's addition, it'll give me 1 if they're the same top and bottom. But you have to remember with addition, order does not matter. So addition reversed will also reduce to 1. It's only subtraction reversed that reduces to -1. So, for example, if I have something like x to the 5th minus 7 over 7 minus x to the 5th, I know we had said originally that we have to factor first, but I don't want to factor something to the fifth power if I don't need to. Does everybody see that these two are subtraction and the order's reversed? And so they're going to be opposites and reduce to -1. And so if I look at another example, let's say I have 9 minus x squared over x squared minus 6x plus 9. Can anybody factor that numerator for me, 9 minus x squared?
X plus 3, x minus 3?
Almost, because it's subtraction, order matters. So are you all right if I write that as 3 plus x, 3 minus x? Because the 9's at the beginning.
Oh, yeah, yeah. Makes
Okay.
sense. Okay.
Great. Right idea. Just remember with subtraction, you have to be careful with your order. Anybody want to factor that denominator for me?
X minus 3 and then another x minus 3.
X minus 3, x minus 3. Beautiful. And now when I look at it to compare to see if I can reduce, there are no factors exactly the same between the numerator and the denominator. But 3 minus x and x minus 3 are opposites. So whatever I get, I can cancel those out if I multiply the result by -1. And so my final answer to show multiplying by -1, we're just going to make it a negative fraction. And it's the negative of 3 plus x over x minus 3. Is that all right?
Yep.
Then we'll look at one more to simplify. And let's look at y squared plus 7y minus 18 over y squared minus 3y plus 2. And I'd like to have you folks try this one on your own first. I'm going to give everybody about a minute and a half. So please remember, fractions are fun if you factor first. So the only hint I'm going to give is make sure you factor before you try to reduce. How's everybody doing? Are we ready to go over yet?
Yep.
Yep. All right. If I were to factor this, I would have started with the denominator because I think y squared minus 3y plus 2 is not too bad. Y squared, the only choices are y and y. 2, the only choices are 1 times 2. Because it's positive, my signs are the same. And if I make them both minus, when I look at the outer and the inner, it gives me the -3. And that gives me hints as to how to factor the numerator. Y squared is y times y. My signs are opposite. One's a plus, one's a minus. And now I'm looking at factors of 18. And I'm looking at what I did already. And I'm kind of making my first guess, 9 and 2. And if I do it that way, I notice I get -2y plus 9y, which gives me that 7. And I've got my common factor. So the final answer is y plus 9 over y minus 1. We good?
Yes.
And so, does
Just a
everybody,
question.
sure.
So for the homework, it wouldn't tell you to write it like that, right? It just tell you to like put a comma in between.
In between what?
Like, so it would tell you to like put it in a pair for the P6 homework.
Uh-huh.
So you wouldn't write it in a fraction like that, like y plus 9. You'd write it like 9 and then comma -1, right? So they accept
Nope.
it. It'd
You
just be like that.
You have to write the fraction like this.
Oh,
Let's,
okay.
let's pull one up. I think
one
you're
of the
thinking about
questions-
the questions that ask about the domain.
Oh, yeah. I think that's
Yeah,
what I'm
yeah,
talking
yeah,
about.
yeah. And so this question, if it asks for the domain, y cannot equal, well, to make that denominator 0, y cannot equal 1 or 2. And so with a comma in between, that's like how they treat the domain questions. Where is it undefined? Instead of the domain, they might say, where is it undefined? And it would be undefined at 1 and 2. There's where the comma's in. But if they're asking you to simplify a fraction, you're going to use it, you're going to have to type the fraction out. Okay?
Okay, thank you. Yep.
All right. Thanks for asking. It's better to get things clarified. If simplifying's all right, then the next thing that we're going to do is we're going to multiply rational expressions. And what I want to ask you to remember is way back when, a million years ago, when you were first learning operations on fractions, does everybody remember if I have A over B times C over D, when I multiply fractions, I take the product of the numerators over the product of the denominator. Sorry about that, denominators. And then I simplify, multiply straight across. And so to multiply rational expressions, because we just multiply straight across and then simplify, the first thing we're going to do is we're going to factor each numerator and denominator completely. And then because the product, we can kind of just think of it as one great big fraction, product of the numerator over the product of the denominator, we're going to simplify the fraction formed by the product. Not formed. Of the factors. You're going to find that most times they let you leave your final answer in factored form. And so what you really need to remember to do is if you see a multiplication problem, what you should really be seeing in it is 4 factoring problems. What do I mean by that? if I look at 6x plus 9 over 3x minus 5 times x minus 5 over 4x, pardon me, plus 6. I like to say that fractions are fun if you factor first. So the first thing you have to do is factor. There are some people who are gluttons for punishment and look at this and just start multiplying. Don't. If you start multiplying, it just gives you something bigger that you have to factor to simplify. Your best bet is to always factor first. First numerator, 6x plus 9. Does everybody see there's a common factor of 3, leaving me with 2x plus 3? Then I have to apologize. This 5 should be a 15 in this first denominator. I'm so sorry. Then factoring that denominator, there's a common factor of 3 and x minus 5. Next fraction, x minus 5 does not factor. And then 4x plus 6, does everybody recognize, because they're both even numbers, there's a common factor of 2. And I have 2x plus 3. Everybody with me in terms of the factoring? Nobody's answering. Oh boy. I'm going to go on the assumption that everybody who's quiet, they're okay. So now I'm going to treat this all as one great big fraction. And in that one great big fraction, I can divide numerator and denominator by 3. I can divide numerator and denominator by 2x plus 3. I can divide numerator and denominator by x minus 5. And so if everything's divided out of the numerator, there's a factor of 1 left. And in the denominator, there's a factor of 2. And so my final answer is a half. How's that one?
Good.
Thanks. Then, oh, that's the first time my finger wanted to act like a pen on this. Next example. Let's look at x squared plus 6x plus 9 over x cubed plus 27 times 1 over x squared minus 9. And again, simplifying, we factor first. Multiplying, we factor first. You're going to find, hopefully you notice there isn't a heck of a lot of difference between multiplying fractions and simplifying fractions, except we have more factoring to do. Can anybody factor that first numerator for me? X squared plus 6x plus 9. You guys are awfully quiet today. X squared is x times x. The signs are the same, both positive. 9, if I think of it as 3 times 3, when I look at my outer and inner, it'll give me the 6x back. Denominator, that x cubed plus 27. There's nothing in common. And so I see that x to the third, and I think, is that the sum of cubes? Is there a number that I can raise to the third power and get 27? The cube root of 27 is 3. So that'll be, since it's a plus sign, this will be x plus 3. Then it's the first one squared, x squared. The opposite of this sign, minus, the product would be 3x. Then the last one's always plus, and the last one squared will be 9. This trinomial usually does not factor. 1 does not factor. And x squared minus 9, 2 terms, both squares. Because there's a minus sign in between, my signs are different. And so it'll be plus 3 minus 3. Now, when I look for common factors, there's a common factor of x plus 3. There's another common factor between the numerator and the denominator of x plus 3. And so I'm left with 1 over x squared minus 3x plus 9 times x minus 3. That one all right. If so, I'm going to give you guys one more to try on your own. I'm going to ask you to take a couple minutes and tell me what you get. Last example of just multiplication is going to be x squared plus 5x plus 6 over x squared plus x minus 6 times x squared minus 9 over x squared minus x minus 6. And so could everybody please factor that as much as possible and then simplify. I'll give you a minute or so. How's everybody doing? Are we ready to go over? Or do I need to wait a minute?
Just give me another minute.
Okay. Ready? All right, who can factor for me the x squared plus 5x plus 6?
Would be the numerator would be x plus 2, x plus 3.
Beautiful. Do you want to give me that denominator also?
No, I didn't figure that one out.
Okay, all right.
Is it x plus 3, x minus 2 for the denominator?
X plus 3x minus 2 would give us that denominator. Beautiful. How about that next numerator?
X plus 3, x minus 3.
X plus 3, x minus 3. And that next denominator? I'll do the hard part, x and x.
I usually just get confused on the sign, like the minus and minus. I don't like remember if it's supposed to be plus and minus or like if it.
Okay, I'll tell you what, because that's a negative sign, it tells me that one's a positive and one's a minus. It doesn't really matter which goes where.
Okay.
Now, 6 is 2 times 3. What matters is with the 2 and the 3 to get the negative 1 in the middle, which should be negative? Should it be negative 2 and positive 3? Or should it be positive 2 and negative 3? Which combination would give me the negative 1 in the middle? And I think if you have positive 2 and negative 3, let's see, that would be first x squared minus 3x plus 2x, which gives me that negative 1. Any better? And now we get to, that's the factoring is the hard part. Once we've got that done, we can have fun. I think crossing things out is fun. So we can have fun reducing. There's a common factor of x plus 3. There's a common factor of x plus 2. There's a common factor of x minus 3. And so my final answer is x plus 3 over x minus 2. And again, usually with these, even if there's more than one factor left in the numerator and the denominator, they let you leave it in factor form. You don't usually need to multiply them out further. And so do you see that in order to do the multiplication, the very first thing we do is factor. And if we factor correctly, then there's not that much left. A lot of it will reduce. Multiplication, all right. It's just a lot more practice factoring.
Yep.
Okay. Then next place we're going is division. If we look at the division of rational expression, I remember when I first learned about how to divide fractions, A over B divided by C over D. Does anybody remember dividing fractions? The rule usually is don't divide, change it into a multiplication problem. Does the idea of keep the first fraction the same, change the division into multiplication, and then I think has anybody heard keep, change, flip? Take the reciprocal of the second fraction. Is that at all familiar? Keep, change, flip?
Yeah.
Yeah. So to divide, what we're going to do is we're going to rewrite it as multiplying by the reciprocal. So we keep the dividend, the first fraction, the same. We change the division into multiplication. And then we take the reciprocal of the divisor which is a fancy way of saying we flip the second. And then we use our multiplication rules. And again, to multiply, oh Lord, how do you spell multiply? We always have to remember that we want to factor. Factor, factor, factor. And I'm hurrying to move this up because my penmanship looks awful today because there's a little bit of a jet lag with the pen, and so my hand's about 3 letters ahead of the pen, and it's confusing the heck out of me. Sorry, folks. Are we ready for an example, or do I need to hold off for a minute?
Good.
We're good? Okay, thanks. So my first example, let's start simple and work our way harder. Let's say I have x plus 5 over 7 divided by 4x plus 20 over x plus 2. Going to rewrite the division as a multiplication, x plus 5 over 7. The dividend, the first one stays the same. The division becomes multiplication, and then I take the reciprocal of the second, giving me x plus 2 over 4x plus 20. Now, I'm going to factor. X plus 5 does not factor. 7 does not factor. X plus 2 does not factor. 4x plus 20, does everybody see there's a common factor of 4? And my other factor, when I divide out the 4, would be x plus 5. Now to multiply, we're going to treat it all as one great big fraction. Pretend that this is one continuous fraction bar. And we can divide out that common factor of x plus 5. And so we're left with final answer, x plus 2 over 7 times 4 will give me 28. And that rewriting the division as multiplication, factoring, and simplifying. Is everybody all right with that?
Yep.
What you have to be careful of with these, is they're going to ask you, I can't remember, I have to apologize if they ask you for the domain, or if they ask you where it's undefined. It's going to be x cannot equal. And what you have to be careful of with these division problems is going to the original division problem. Neither of those denominators can be 0. Well, x isn't, 7 doesn't equal 0. With the other one, the other denominator, x plus 2, if I set that equal to 0, I get x cannot equal -2. But then I also have to worry about the denominators after I flip. And after I flip, I know that 4x plus 20 can't equal 0, which would give me, when all is said and done, that x cannot equal -5. And so here there's two values that we exclude, -5 and -2. And again, be careful. In my labs, a lot of times with these questions, they ask you to put them in order. And I'd hate to have somebody do a second one of these problems over again because they didn't notice that the question said put them in order. So you're better to err on the side of caution and put them in order. That one, all right.
I'm still confused on how you found the domain. I think that's what I found confusing.
Okay, in terms of domain, what you have to remember, I'm going to scooch up. Mini lesson on domain. On domain, with fractions, you have to remember that the denominator cannot equal 0. So to find the domain, we set the denominator equal to 0. We solve those, and we have to exclude the solutions. So if I go back up to the example we just did, when I look at the original problem, I don't care at all about the numerator when I'm looking at the domain. I carry out these denominators. So 7 doesn't ever equal 0, so we don't have to worry about that one. But x plus 2 can equal 0. When x plus 2 equals 0, we get, solving that, we get x equals -1. I'm sorry. No, we don't. We get x equals -2. I'm so sorry. And so x cannot equal -2. The domain would be all the numbers except -2. And what's unique with the division problems is you have to worry about the domain before you flip it, and you also have to worry about the domain after you flip it. And so after I flip it, that second fraction, the new denominator is 4x plus 20. And so that denominator can't equal 0. If I say 4x plus 20 equals 0, I end up getting x equals -5. And so that tells me I have to exclude -5.
All right, that makes more sense. Thank you.
So it's the one question that usually you answer backwards. In terms of saying, where is it defined? We have to say, where is it undefined? What cannot happen? The denominator cannot equal 0. So let's make that denominator 0 and toss out the values that we get. Okay?
All right, thank you.
So let's look at a couple more. Let's look at x squared minus 4 over x squared plus 3x minus 10 divided by x squared plus 5x plus 6 over x squared plus 8x plus 15. Again, it's a division problem, so we're going to leave that first fraction alone. We're going to change the division into multiplication, and then we're going to take the reciprocal of that second fraction. Now that we've got a multiplication problem, in order to multiply, the first thing that we have to do is factor. Where did that come from? Factoring that numerator is x plus 2, x minus 2. That denominator, to get x squared, x times x. Because that's a negative sign, it tells me that my signs are different. One will be positive, one will be negative. Multiply to 10, giving me the -3. I think it's plus 5 minus 2. Then next numerator, I have to factor. X squared is x times x. Because that's positive, my signs are the same. Multiply to 15, give me 8. I think 3 and 5 will do it. And then that denominator, x squared plus 5x plus 6. To get x squared, x times x. Because that's positive, my signs are the same. Because the middle one's positive, they're both pluses. Multiply to 6 and give me 5. I think that'll be 3 and 2. Now, we have to see if there's anything common between the numerators and the denominators. And so let's see, x plus 2, that appears numerator and denominator. X minus 2, that appears both. X plus 3, that's a factor of both. X plus 5, that's a factor of both. And because, well, it looks like I'm just crossing them out, I'm dividing them out. And anything divided by itself gives me 1. That one all right?
Yep.
If so, let's start looking at that next operation. And that next operation is addition or subtraction. Of rational expressions. And I guess I'm wondering how much arithmetic you folks can remember. If I have 3/16 plus 1/4. Can anybody remember what you need in order to add two fractions?
Common denominator.
So you need a common denominator. When I look for the common denominator, we usually look for the least common denominator. Is everybody all right though? I'm not going to use the 4 as my common denominator, but instead I'm going to use the 16. The common denominator has to be divisible by the factors of all the denominators. We look at it as the product of the factors of each denominator. Common factors, we use the highest exponents. And then do you remember, you have to go through and you have to do a bit of work. Once we find the common denominator, the first fraction already has it. The second fraction, we have to make it get that common denominator. And so we ask, what can I multiply 4 by to make it 16? And it's 4. And whenever I multiply it by, I have to multiply the numerator by the same thing. So we have to multiply the numerator and the denominator by the same value to get the common denominator. And so that makes that second fraction 7/16. Oh, no, it doesn't. I'm sorry. I'm half a step ahead of myself. That makes that fraction 4/16. And then you remember to add. We had to work hard to get that denominators. We're going to keep the denominator. We're going to add the numerators. And so that gives me final answer 7/16. And we'll simplify if possible. But this one doesn't simplify. So, does that process look vaguely familiar? It's going to turn out to be a very, very similar process with algebraic expressions as it is with numbers. It just doesn't look quite as elegant when we've got a lot of variables involved. So first, let's look at some examples that do already have a common denominator. Let's look at 3x plus 2 over 3x plus 4 plus 3x plus 6 over 3x plus 4. And when I go to add these, I have the common denominator, so I'm going to keep it. And when I add the numerators, because it's addition, I can just add across. 3x plus 3x is 6x. 2 plus 6 is 8. And it looks like this much might simplify, but remember, in order to reduce, in order to simplify, we can only divide out factors. So we have to factor first. 6x plus 8 has a common factor of 2. When I divide it out, I have 3x plus 4. Now I can cancel that common factor. My final answer is 2. If they already have a common denominator and we're adding, is everybody all right?
Yep.
Instead, if they already have a common denominator and we're subtracting, my directive to you with subtraction is make sure to watch your signs. Be very careful with your signs. What do I mean by that? Let's look at 2x plus 3 over 3x minus 6 minus 3 minus x over 3x minus 6. And when it's subtraction, I take the time to rewrite it. I have my common denominator. I'm going to keep it. Everybody all right with that part?
Yep.
But then I have to subtract the numerators. And if the numerators have more than one term, I like to rewrite that subtraction problem as the difference of the two. Here it's the difference of the two binomials. Why do I do that? Because it keeps me from making a subtraction error. Does everybody remember when we were subtracting binomials, polynomials, we said we want to put that 1 in front? And so that becomes 2x plus 3, and we have to distribute the negative 1. And then, so it becomes minus 3, minus times minus plus x. It changes all of the signs after the subtraction. And so now when I combine 2x plus x is 3x. 3 minus 3 is out of there, it's 0. So then when I have in the denominator 3x minus 6. And doesn't it look like that fraction should reduce? But again, you have to be careful. You can only simplify if you factor first. So here, 3x doesn't factor. Does 3x minus 6 factor? Is there anything in common? Everybody write that denominator. There's a common factor of 3. When I divide it out, I've got x minus 2. Now I can divide out the 3. So my final answer is x over x minus 2. And so you see, you have to be super careful if you're subtracting. You really, really, really have to watch those signs. And I'm looking at my watch, and I'm looking at what comes next. And so we're going to stop with that example. And so next class, we'll look at adding and subtracting rational expressions with uncommon denominators and complex fractions. And that'll be the last new thing that we cover before that test. And so on Wednesday, we'll clarify any problems you have with the homework. And do you guys want to go through one of those problem sets, one of those practice tests together as a class before I send you on your own to take your test? Would that be helpful?
Yeah.
Yeah. So we'll plan on doing that then on Wednesday. And then after Wednesday's class, before Fridays, so from the end of class time Wednesday till midnight Tuesday, you'll take that test on your own. It's a time test. You'll have the length of the class time, which is 75 minutes. All right? Otherwise, I'm going to stop sharing. I'm going to stop recording.